Welcome back. Now in this lesson, let us discuss about some buzzwords that are miscellaneous and that you might come across. Let's start with the cloud computing. You might have heard of this. Many people think that the cloud is some magical place where your data floats around. Here's the truth. There is no such thing as the cloud. All the cloud computing happens in physical servers located in some data centers. So what is cloud computing all about? Let's break it down with the help of a simple example. Imagine you want to create a website like sweetcody.com. Now to host your website, you definitely need servers, that would host your website data, that would host your business logic. Now here's the challenge. You can buy the physical servers yourself and then maintain it and develop it. But buying and maintaining the physical servers is expensive and time consuming. You'd have to purchase the hardware, maintain the servers, take care of their security, backups, power supply, and then replace them when they break down. This is where cloud computing comes in to save the day. So instead of buying and maintaining the servers yourself, how about this that you rent them from famous companies like Amazon, Google, or Microsoft? These companies have huge data centers full of the servers that are ready to use for you. So how does it work? Let's say you're trying to host sweetcody.com. The user visits sweetcody.com on their device. The client sends a request to this server that is now hosted in the cloud, which might be AWS, which might be Azure, which might be Google Cloud. The server then fetches your data from the data store, and finally the server sends the web page back to the user's device. So all this part that is highlighted here is actually rented from the famous cloud providers. By the way, a fun fact. Did you know that AWS, which is the famous cloud provider service by Amazon, started as an experiment? Amazon originally built AWS just to handle their own retail business. But then they realized, hey, we could rent out this infrastructure to others. And today, AWS is the biggest cloud provider in the world. Now, talking about what are the benefits of cloud computing versus actually physically purchasing your servers and maintaining it. First is scalability. When we use the cloud, it lets you increase or decrease your server capacity instantly. All of this is managed by these big companies. You don't need to buy new servers when your website gets more visitors. It would be a simple configuration change, and all these things would be handled by these famous companies. Second, this is super cost effective. Why is this the case? Because you only pay for the server resources you actually use. So if perhaps during the holidays your traffic shoots down, you can actually decrease your server resources. Would be again a simple configuration change. This is in contrast where you actually own the physical servers and then you have to shut them down and whatnot. This would make it cheaper than maintaining the physical servers for sure. Third is reliability. Using the servers from the cloud is super reliable option because all these big giants, big companies would handle the maintenance, security, and backups for you. So definitely these big giants can handle these aspects much better than you yourself or your small individual company. Cloud computing has transformed how the websites and apps are hosted. Instead of worrying about the hardware, you can actually focus on building your business, while these cloud providers like AWS, Azure, GCP, they would take care of all the infrastructure. Stay tuned for the next one. Now let us understand another two important buzzwords, which are logging and monitoring. So logging is just like a computer writing his diary. Just as you write down important events, thoughts, or issues in a diary, the server also logs all of its key activities, like what requests it is executing, how it is executing, what responses it is giving back to the client, any errors that it faces, or any other important notable system events. All of this, it logs in its diary. This is what logging is essentially. You can think of logs as footprints left behind. If something goes wrong, developers can go through these logs and figure out what exactly caused the issue. So it would even help in troubleshooting. Now in the first diagram, you can see that the server is writing its diary whenever it gets a request. It notes down each of these steps so that we have a record of what exactly happened. For example, the client here demands the website homepage in this process. The request is sent to the server, and this is what the server logs then. The client has demanded homepage from me. Perhaps it would then log, I need to retrieve the website assets from the object storage. Once it has actually retrieved them, perhaps it can log, I have successfully retrieved the website assets from object storage. Ultimately, just before sending these website homepage back to the client, it can log, I'm sending the website back to the user. So effectively, the server is writing diary and keeping a track of what exactly happened throughout this process. Now let's come to the monitoring. Monitoring is just like having a security camera that is watching our server's diary. So if something goes wrong, alerts are triggered to notify the developers that, hey, perhaps this has gone wrong and you need to take a look and fix it. Let's take a look at the example. You can see in the diagram that, again, the client requests the website homepage. Now the server starts logging all of these events as we have discussed. Now if perhaps, let's say, there is an error when it tries to retrieve the website assets, which is marked as red in this logs, then our monitoring system will catch this. Once it has caught this, it would send an alert to the developers. The developers can then take a closer look at our system and then try to fix the issue. So this monitoring system effectively ensures that we catch the errors or anything that requires urgent attention and then conveys that to the developers so that it can be fixed ASAP. Now, what is the importance of logging and monitoring? Pretty intuitive, right? Logging would help us understand what exactly happened, giving a detailed look when required. And monitoring, on the other hand, would help us send alerts to the developers when something happened that shouldn't happen. Together, these processes would help our systems stay healthy and efficient, making sure that issues are identified and resolved quickly and efficiently before they affect our users. Now, in this lesson, we'll be looking at two common caching strategies, which is the cache aside strategy and the read-through strategy. Caching is a technique that is used to speed up the data retrieval by storing frequently accessed data in a fast access cache, rather than repeatedly querying a slower database. So first, let us take a look at the cache aside strategy. So how does it work? When the data is requested, the server would first check in the cache to see if the data is already available. If the data is not found, aka a cache miss, then the server would retrieve this data from the database and then it would store in the cache so that it will be available for any other future requests. Let us take a look at the diagram to understand this better. User 4 makes a request. When the request comes to the server, the first thing that the server does is check if user 4's data is already in the cache. This is the step 1 that is highlighted in the diagram. Now, since user 4's data is not present in the cache, that is, it is a cache miss. Now, in this case, the server would fetch this data from the database that is highlighted in the step 2. Now, after getting the data from the database, the server would then update the cache to include the user 4's data in the cache. This is because next time there is a request for user 4, we can just quickly retrieve it from the cache without going to the database. Now let's move to the read-through strategy. Now in the read-through strategy, the cache itself would be responsible for fetching the data if it's not already present. So when the server requests the data, the cache will first check if the data is available. If not, the cache itself would fetch that data from the database and save it in the cache for future requests. Now you can take a look at the diagram to understand this better. A request comes from user 4. The request comes to the server, which would first check the data in the cache for user 4's data. Now, if user 4's data is not found in the cache, which is the case here, instead of the server fetching the data from the database, this time the cache would fetch the data from the database. After fetching the data, the cache would then update itself with this data for all the future requests, so that next time there is a request for user 4's data, it will be found in the cache. This strategy is called as a read-through strategy because effectively the server is reading the data from the database with the help of a cache, or it is reading through the cache. So it simplifies the logic at the server side, as the cache itself would be handling all the interactions with the database. In both of these strategies, the goal is to minimize expensive database reads by using the cache for frequently requested data. Now let us take a look at the 3 common caching strategies, but for the writes. First would be the write aside strategy. Now in this strategy, as it is very evident from this diagram that the data is directly written to the database, bypassing or ignoring the cache at all. Now you might wonder, how does the cache gets updated then? Well, this happens during the read process. When the data is read, the system first checks the cache. If there is a cache miss, or if the data is not found in the cache, then the data is fetched from the database and then the cache is updated. So basically the cache gets updated reactively or on demand rather than proactively. This is why this approach is also known as lazy caching. Next is the write-through strategy. Now this is very similar to the read-through strategy that we saw as one of the reading strategies for the cache. In this strategy, every time the data is written, it's first written to the cache. Then the cache immediately updates the database and then it sends the confirmation back to the application or the caller. Now this process happens synchronously. Basically, step 1 followed by step 2 followed by step 3, and only then there is a confirmation sent to the application. So basically the caller or the application is assured that whenever it gets the confirmation from the cache, then the database has already been updated. Next, let us move to the write behind strategy, which is our third type of write strategy. Now this strategy is quite similar to the previous one, which is the write-through strategy. Basically, whenever the data is written, it's also first written to the cache and then the cache would update the database. The key difference here that you can also spot from the diagrams is in the step numbering 1, 2, 3, and 4. Basically, the steps 3 and 4, that is the update from the cache to the database, is happening asynchronously here. So effectively, an application tries to write the data to the cache. The cache would update itself and then send the confirmation to the application here. Now, after sending the confirmation to the application, it would then update the database with this new value. So basically, the steps 3 and 4 happen asynchronously here. Now, we have already studied about the different read caching strategies. We have studied about the cache aside strategy and the read through strategy. Let's now dive deeper into them and see the pros and cons associated with each of the strategies. First is our cache aside strategy. Now just recalling, in this strategy, the application would first check the data in the cache. If there is a cache miss, it would check the data in the database and subsequently it would then update the cache with that data for all future requests. Now the first pro with this strategy is increased fault tolerance. Why is this the case? Consider that our cache fails for any reason. In this case, the system doesn't break. The application can still read the data directly from the database, even though it may be a bit slower, but our operation doesn't face a downtime. So basically, since we have kept the cache as separate, hence cache aside as it's called, therefore it doesn't impact our uptime, even if the cache goes down. Second pro would be flexible schemas or flexible data models. Now in this case, since the application controls the cache, basically the application is responsible for updating the cache. Consequently, we have more flexibility in how we can store the data. The cache and the database can have different data structures. For example, the cache might only store commonly accessed details like user's name and contact details, while the database can hold the complete user profile. So there is an increased flexibility in data modeling. Now let's come to the cons. There is one main and primary con associated with this, which is the problem of stale data. Now let's say there is a user record, example user 4, that is initially only present in the database and not in the cache. Now when a read request comes in, there is a cache miss. There is a cache miss because our cache doesn't have this data yet. So we fetch the user 4's data from the database and then save it to the cache. Now all the future requests from this point for user 4's data will be served from the cache. But what happens if, meanwhile, the user 4's record in our database is updated? Let's say their address changed perhaps. In this case, our cache still holds the old address since it was never refreshed. Now if we get another request for user 4, it will still serve the outdated address from the cache. Now this is a problem. Now to avoid this, what can we do? We can periodically remove the old data from the cache, a process we call as the cache invalidation. Now after invalidation and eviction of that old data, whenever the next request for user 4 comes, we will have a cache miss. Now basically we have forced a cache miss with our cache invalidation and eviction. Now whenever we have a cache miss, what will happen? We'll fetch the updated data from the database and then our cache will be updated with this updated data. Let's now move to the read-through strategy. Just summarizing it once again, the reads in the read-through strategy happens through the cache. Basically, if the data is present in the cache, it would be served. If it's not present in the cache itself would read it from the database and then the data would be served to the application. Now, what are the pros of this approach? There is no stale data problem here. If we pair the read-through strategy with our write-through strategy, which is commonly the case, then we can be assured that the data in the cache would always stay fresh. Basically, every update that will happen with the help of write-through strategy. For example, let's say a change in user 4's address. Now, whenever this happens with the write-through strategy, we can be assured that it would be written both to the cache and the database synchronously at the same time. So whenever we read the data from the cache, it's guaranteed that the data would be up to date and fresh. Now let's come to the cons. First, cache failure can cause a downtime. Now if the cache fails for any reason, the application cannot read data directly from the database because in this strategy, all the reads go through a cache. So the cache failure could make the whole system unavailable. Second is less flexibility or less customization in our data modeling. Now, in this approach, the cache and the database, they need to have the same data structure. Definitely, this limits the flexibility since we cannot customize what is stored in the cache. Now, let us look at the pros and cons of the write caching strategies that we have discussed. First, let us take a look for a write aside strategy. Now, in the write aside strategy, we directly write to the database by passing the cache at all. As you can see in this diagram that there is an arrow 1 which is directly writing from the application to the database. Now what would be the pros of this strategy? Think about it. First and very obvious one is that we have faster writes here. Why faster writes? Pretty simple, right? The data is directly written to the database. We don't need to update or write to the cache. Now since we only write once and that is to the database, writes naturally become faster. This is in fact a great strategy for write heavy operations or write heavy systems where we don't need to update the cache immediately. Second is cache independence. Now what do I mean by this? Basically in this strategy, the cache is kept separate and doesn't directly sit in the middle of the write process, but rather it is kept aside, hence the name write aside strategy. So this effectively means that even if the cache fails, it won't affect the database writes. So the system can keep working even if, let's say, the cache is temporarily down. So basically we have increased fault tolerance of our system. Now for the cons, firstly, there would be slower reads. Why? Since we are bypassing the cache during writes, the data won't be available in the cache right away. Now, when we try to read the cache, it could lead to a cache miss, therefore requiring the data to be fetched from the database first and then added to the cache. Now, all of this, cache missing, getting the data from the database and then the cache getting updated and then serving the data to the users would make our reads pretty slow. Next, we have the risk of stale data. Now, what do I mean by this? Let's say we update a user's address in the database using this strategy. Now, since the cache was bypassed, it won't have this updated address. Now, if the cache already has this user's data, it will be the old or the stale version without this new address. So wherever there is a read request of that user's data, it would serve the data from the cache first, and therefore the data with the older version or the older address would be served. In fact, we would have to wait until the data in our cache expires and is invalidated and removed from the cache. This is only when we would face a cache miss, and then the cache will be updated with this updated data or our new address. So basically, we have the stale data problem, and only cache miss would update that stale data to the new data. Next, let us move to the write-through strategy. Now, in the write-through strategy, the application first writes the data to the cache writes it to the database sends a confirmation back to the cache, and then the cache would send a confirmation back to the application. So the pros. First, we would have no stale data here because every write operation, whether it is creating a new record or updating an existing record, and they would go through both of these cache and the database at the same time, or aka synchronously. So if we change, let's say, a user's address, it's updated in both the places instantly, keeping the cache and database perfectly in sync at all the times. Second, we have faster reads here. Now, reads here are pretty quick, unlike the previous strategy. This is because the data is always available in the cache. Unlike the write aside strategy, we don't have to wait for the cache miss to update itself, since the data is already cached on every write operation. Let's come to the cons. The first con here would be slower writes. Now here, the writes would become slower when we compare it to the previous strategy because each operation would update both the cache as well as the database. Now in the previous strategy, we only wrote to the database, but here there is now an added extra step with the cache, adding to the latency. Second is cache dependency. What does this mean? Now in this strategy, the cache becomes a crucial component because all the writes would go through the cache first. Naturally, if the cache fails, we cannot write to the database, which could cause the whole operation to fail and could lead to system downtimes. Now let's move to the write behind strategy, which is sort of an improved version of write through strategy. Now here, unlike the previous two strategies, we would have best of both the worlds. We would have faster reads as well as faster writes. Let's see how this works. First, the application would send the write request to the cache would be updated with this data, and then a confirmation is sent back to the application. Then the steps 3 and 4 will happen, which is effectively cache updating the database. Now the steps 3 and 4 here would happen asynchronously or in the background, and this would happen after we send the confirmation back to the application. Basically, our application doesn't have to wait for both the cache and database to be updated before receiving the confirmation. It could get the confirmation just after the cache is updated, and the cache to database would be updated behind the scenes asynchronously. So what would be the pro of this strategy? Faster writes. Now this strategy solves the slower write problem pretty smartly. When the application writes data, it goes to the cache first, cache updates, and the application then immediately gets a confirmation. After that, as you know, the cache updates the database asynchronously in the background. Second, we would have faster reads here. Now reads are also faster here, pretty obvious because the data is written both to the cache and the database, and therefore whenever there is a read operation in the future, it could be served from the cache. Let's come to the cons. Now the first con would be risk of data loss. Basically, the asynchronous database update happening from the cache to the DB is efficient and it helps to solve the slow write problem, but it can also lead to issues on the other side. For example, if this background asynchronous update from the cache to the DB doesn't go through for some reason, then the data won't ever reach the database. Now, since the cache is volatile and is temporary, it could lead to data durability issues in those cases. Second is cache dependency. Just like the previous strategy, the cache sits right in between the application and the database. Every write goes through the cache. So if the cache fails, we cannot write to the database, which could lead to downtime for that operation and also for our system.